So this is just a review from yesterday. If this were a quadratic, a difference of two squares, you would be able to square root it and square root it. So it is a difference of two squares. You are able to square root this right here and square root that right there and plug it into your answer format, binomial, binomial. It's still equal to 0. But the square root of t to the fourth is t squared. Okay, so you'd put a t squared on both. Now, just as a side note, like some people might not remember how the square root of t to the fourth is t squared. Let me show you. So this is not part of the problem. I just want to explain to those that might be lost. If you have t to the fourth power and you square root it, you need to understand that a square root is really the power of 1/2. So you really have t to the fourth power to the power of 1/2. And we know, based on the rules of exponents, that when you have a power to a power, you multiply. 4 times half is 2. So that's how we get the square root of 4 being t squared. So that's just an explanation of how we got t squares instead of, or from that t to the fourth. Okay? And now let's do the square root of 16, which is 4, and you put the 4 right here and right there. And of course, there is no middle term, which means that one has to be plus, one has to be minus, and it doesn't matter which one it is, plus or minus, right? So what we have here is now something times something equals 0, which means we could use the zero product property to split them and set them each equal to 0 and solve. Or if I wanted to, I could say, wait, I have a difference of two squares again, which means I could split it further. So it's up to you guys. Do you want to factor further and then split everything, or split it now and then solve? What do you guys say? You want me to continue factoring this guy, or do you want me to just split them? There is no wrong answer.
Split.
Split them. All right, so if we split them, we're going to have t to the second plus 4 set equal to 0, and t to the second minus 4 set equal to 0. So let's solve both. You're going to subtract 4, subtract 4. You will have t to the second equals negative 4. Of course, you need to solve this thing, and the way to get rid of a t to the second is to apply a square root and a square root. So you will have t equaling plus or minus, the square root of negative 4 is 2i. So these are two answers to our quartic equation so far. Now the other one, you would solve by going plus 4, you will have t squared equaling positive 4. So right here where you apply a square root, you will actually get two real answers. T equals plus or minus 2. So if I were to graph this quartic equation, like let's say f of t equals t to the fourth power minus 16, if I were to graph it, it will have end behavior in quadrant 1 and quadrant 2. Quadrant 1 and quadrant 2, because it's an even degree function and the coefficient, leading coefficient, is positive, so it will have end behavior in quadrant 1, quadrant 2, and it will go down, and some curves will go, you'll change direction 4 times, but it will only cross the x-axis at positive 2 and negative 2. So it only has two real answers. 2 imaginary, 2 real, okay? Let's use that skill that we learned yesterday, or let's review that skill that we learned yesterday of taking a higher degree polynomial and making it look like a quadratic. Now, yesterday I did say that we could actually substitute, right? Substitute a red x in place of the t's. Now, let me just reiterate what we learned yesterday. Instead of t to the fourth, I could look at this as something squared. And instead of minus 2 t to the second, I could look at it as minus 2 times that same something, and then minus 8 at the very end equals 0. Now, what would have to belong in here in order to make this quartic look like a quadratic? Well, you first have to make sure that your degree, your highest power, is twice as much as the middle term's power. Okay, and it does satisfy that. If you have a 4 and a 2, it's good. If you have a 10 and a 5, it's good. If you have a 6 and a 3, it's good. Right here, 4 and 2, yes, you could do this, which means you could do the parentheses squared minus 2 times parentheses instead of that. And you think, what belongs inside this parenthesis? Well, that would be a t squared. So let's put a t squared right in there and a t squared over here. And now this does look like a quadratic. Now, yesterday I said if you want, you could substitute a red x in place of that blue t squared. And I put a little cloud around it. That way it was crystal clear that it looked like x squared minus 2x minus 8 equals 0. Now, I'm telling you right now, it's technically an unnecessary step, all right? Now, you could, if you want to, substitute. If it makes you feel better, go for it. Replace the blue t squares with the red x so it'll clearly look like a quadratic trinomial. But I am simply going to continue solving this thing, just pretending that you have something squared minus 2 times something equals 8, and just factor it, pretending that those would be x's, right? But instead of x's, we actually have those t squares. So you don't have to do the substitution that I did yesterday. That was just to make it crystal clear for you guys what we're doing. Right now, I'm just continuing with the t squares instead of the x's. Same deal though. I think what times what is my c value that if I combine together is my b value, -2. If you need to, make a list. What times what is -8? You have -1 times 8. You have -2 times 4, and that's about it. That's the only two possible combos of multiplying together to get -8, besides changing signs. So which pair of numbers combines together to give you the middle value b, which is -2? Well, if you add -1 and 8, that'll give you a +7. That's not it. If I add -2 and 4, that'll give me a +2. And I know that I want a -2, which means that I have the right numbers, just the wrong signs. So I'm going to change it to a +2 and a -4. And that's what belongs in here, a +2 and a -4, equaling 0. So whenever you see a higher degree equation, first check if your degree is twice as big as your middle term's power. Then you'll be able to rewrite it to make it look like a quadratic, like a x squared minus 2x minus 8 equals 0. And then you'll be able to think what times what is c that if you combine together is b. That is if it's factorable, right? So now we have something times something equals 0, which means we could split those somethings and set them each equal to 0. We're going to have t squared plus 2, set that equal to 0. T squared minus 4, set that equal to 0. And when we solve this thing, we're going to subtract 2. We'll have t squared equaling -2. I will have to apply a square root and a square root, giving us t equaling plus or minus. You always put a plus or minus when you apply a square root in an equation. And you will have an I, because the negative inside of the root will produce an imaginary. And the square root of 2, we're just going to leave it the square root of 2, which is technically an irrational decimal, a long, crazy decimal. Let's do the other one. The other one's a little nicer. Plus 4, you're going to have t squared equaling 4. And when you apply a square root to both sides, you will get t equaling plus or minus 2. And those are two real answers. So let's get this straight. For a fourth degree equation, we actually get 4 answers, okay, on this one. We get 2 that are real and 2 that are imaginary. So we get 2 real answers, we get 2 real roots, 2 real x-intercepts, 2 real solutions. The other 2 are imaginary. If I were to graph it, this quartic trinomial function would intercept the x-axis at +2 and -2. So that's what we learned yesterday, all right? And hopefully we're good at that and we are able to apply that on this Friday's quiz. We're also going to learn today these 2 new formulas. There's no way around it. We have to memorize it. Now, I do have a little trick that'll help you memorize it. This formula is called the sum of 2 cubes and also the difference of 2 cubes. Now, what does sum mean? It means to add. What are cubes? You have cube terms like something cubed plus something cubed, right? So whenever you have something cubed plus something cubed, you'll be able to identify your a value and your b value, and this is the part that you have to memorize. The binomial times the trinomial, and plug in your a plus b times a squared minus a times b plus b squared. I know you're thinking, dang, I have to memorize all that? Yes, we do. However, I'll teach you a couple of tricks that'll make it really easy to memorize. So here's the trick, guys. Let me zoom in so you could see it. If you have something cubed plus something cubed, we know it's going to be a binomial times a trinomial. Okay, now the binomial will be identical to this, but without the cubes. Simple as that. If you have something cubed plus something cubed, it's going to be that something plus that something as your first binomial. And it's true also for the difference of two cubes. You have something cubed minus something cubed. This first binomial will be that term minus that term without the cubes. You guys following me? So the first binomial is really easy. It's the same exact thing, but without the cubes. First binomial is easy. It's the same exact thing, but without the cubes. Okay. Now the trinomial is where it gets a little bit more fun, but it's not that confusing either. Why do we start with A? Because A comes before B, all right? So we have A squared, and it is positive. We have AB in the middle, and we have B squared at the end. Now, what you have to remember is if your original binomial is a plus, then your AB will be a minus. It'll be opposite. That's the only kind of challenging part. If your original binomial is a minus, then your AB will be plus. It'll be opposite. Okay. Now, what about the A squared? That's always positive. Whether it's the top formula or the bottom formula, it's A squared is always positive. Even the B squared is always positive. It doesn't matter which formula it is. Okay. And how could you help memorize that? Well, it's logical that if you square anything, -3 squared becomes +9. -5 squared becomes +25. Squaring anything will make it positive. So that'll help you remember, oh, my A squared term, that's always going to be positive. My A squared is always going to be positive. My B squared is always going to be positive. My B squared is always positive. So it's really simple. If you have a sum of two cubes, write that same binomial without the cubes. Then you put A squared, AB, and B squared. And if this is a plus, then you're going to put this as a minus. If this is a minus, you're going to put this as a plus. And voila, you have your memorized formulas, or your formulas memorized. Now, let's learn how to apply. Now that we memorize them, or hopefully are starting to memorize them, let's learn how to apply them. You must set this up, parenthesis cubed plus parenthesis cubed, or you must set up parenthesis cubed minus parenthesis cubed. If you do not set this up, you will not truly identify the values that belong in the formula itself, all right? So I know you're thinking, what? Let me show you right here. They want us to factor this. And even before doing the formula, we have to get comfortable with cubed terms, perfect cubed terms. Kind of like we're comfortable with perfect square terms. Everybody knows that the square root of 25 is 5. Everybody knows that the square root of 81 is 9 because we're comfortable with perfect square terms. What are perfect cube terms? 1 is a perfect cube number. Why is that? Because 1 cubed is 1. 1 times 1 times 1 is 1. The next perfect cube number is 8. Why is 8 a perfect cube number? Because 2 times 2 is 4 times 2 is 8. What's the next perfect cube number after 8? Anybody? If you know it, say it. What's the next perfect cube number after 8?
Is it 27?
It is 27. Thank you so much, Jack. You helped me from making that more weird. Yeah, 27, absolutely. 3 times 3 is 9, times 3 is 27. What's the next perfect cube number after 27? Gets a little bit more tricky, huh?
64?
64, that's right. 4 times 4 is 16, and 16 times 4 is 64. How about the next perfect cube number after 64? That one's a little easier. Come on, people. What's the next perfect cube number after 64? How did we get 64? 4 times 4 times 4. What's the next perfect cube number? 5 times 5 times 5, which is 125, ladies and gentlemen, right? So we need to get comfortable with these perfect cube numbers to be able to recognize when we could apply the sum or difference of two cubes. We see the 8, we should know that that's a cube term, all right? So like I said up here in our notes, it's important that we set this up before applying the formula. So before applying the formula, I must set up parenthesis, 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 parenthesis with a cube up here, cube up there, and the minus sign between the two, because this is a difference of two cubes, all right? Now, if I do not set this up, I will not know what to plug in for A. I will not know what to plug in for B. A lot of people, if they don't set this up, they're going to think, oh, I need to plug in the 8 for my B value, and that would be wrong. B is not 8. What number actually belongs here that will give you an 8 at the end of it all? The number 2. Yes, that's right, whoever that was. Oh, that was myself. So the number 2 is the B value, and the A value is X. All right, so you need to set this up in order to identify your A and your B on the formula. So let's begin this problem. We already identified the A and the B. Let's begin this problem by actually writing the difference of 2 cubes formula. So let me write the difference of 2 cubes formula. That is when you have something cubed minus something cubed equals a binomial times a trinomial. Could somebody tell me the binomial? On the formula, not on these values, but on the actual formula itself.
A plus B.
Very close. The binomial will be the same exact binomial here, but without the cubes. So it will not be A plus B, but it'll be A minus B, right? A minus B. We put the minus in a different color. Okay, now the trinomial is A squared. What did I do here? Whoops, my bad. The trinomial is A squared, AB, and B squared. Now we know A squared is positive, anything squared is always positive. We know that if your binomial was negative, your AB has to be the opposite of that, so in this case positive. And we know that B squared is always positive. So you see how I'm applying those tricks to be able to help me memorize this formula? Whatever it starts with, if you have an A cubed minus B cubed, your first binomial will be A minus B without the cubes. And then you have your A squared, your AB, and your B squared, and if this was a minus, that middle term's a plus. The A squared is always positive, the B squared is always positive, because whenever you square something, you always end up with a positive. So with that said, we already have our formula written down right there. Now let's apply it because we know what A is and what B is. So let's apply it and let's write our binomial times our trinomial. Now the binomial should be easy. What is the binomial when we plug in that A value of X and the B value of 2? Could somebody tell me what belongs in here? X
To the third power minus 2 to the third power.
Okay, so check this out, guys. It looks like we're missing the mark here. If you have something cubed minus something cubed, that is a difference of 2 cubes. And what is this binomial? It's the same exact thing as this, but without the cubes. So that would just leave you with the x minus 2. There it is. That's your first binomial. Is that making sense? Okay, so now it's time for the trinomial. The trinomial is a little bit more challenging, and I do recommend using parentheses. On this one, parentheses are not necessary, but I do recommend it in the future, so you might as well practice with it right now. Instead of a squared, let me put parentheses squared. Instead of plus ab, let me put plus parentheses parentheses. Instead of plus b squared, let me put parentheses squared. Okay, so we know that our a value is x, so you put an x in there and an x right there. We know that our b value is 2, so you put a 2 right there and a 2 right there. So of course our trinomial will be x squared plus 2x plus 4. Now, I know you're thinking, why the heck did you use parentheses? I already know x squared is going to be x squared. I already know that x times 2 is 2x, and I already know that 2 squared is 4. The reason why we want to practice using parentheses is because later on in the future, like on the next problem, you might have like a 27x to the third, which means that right here you would have a 3x as your a value, which means that you would have to have a 3x right here instead of x. And if you did have a 3x right there without the parentheses, you probably will make the mistake of thinking that your answer is going to say 3x squared. But if you had a 3x in there, that would actually be 9x squared down here on your factored form answer. So it's very important that we practice using the parentheses on the trinomial. But in this case, it wasn't absolutely necessary, but it's good to practice it because you will need it in the future. So we have that trinomial. We have the binomial x minus 2 right in front. And that is our factored form. Believe it or not, if you were to distribute x times x squared, x times 2x, x times 4, negative 2 times x squared, negative 2 times positive 2x, negative 2 times positive 4, and combine like terms, everything will cancel except for the x to the third and the minus 8. because after all, factoring is reverse distributive property. So if I distribute, I will get back to this original cubic binomial. Pretty cool, right? All right, let's try another. So that was a difference of two cubes. Right here, believe it or not, we have sum of two cubes. Now, how could I identify this? Like I said, get comfortable with those perfect cube numbers. The number 1 is a perfect cube number, the number 8, the number 27, the number 64, the number 125, and of course, if you need higher ones, just do 6 times 6 times 6, and it'll give you that perfect cube number. But anyways, we have 8c to the third and 27d to the sixth. The question is, are we able to write it as a sum of two cubes? What belongs in that first parenthesis in order to get 8c cubed at the end of it all? What belongs in here in order to get 8c cubed if I were to multiply this with itself 3 times? 2c. 2c. Thank you very much. So if we do 2c, of course, 2c times 2c is 4c squared times another 2c will get us back to that 8c to the third. Make sense? Okay, now how about this one? This one's a little bit more tricky, and it's okay to guess, and we could check, and if it doesn't work out, then we'll guess again, right? So what do you think is going to belong in here? The 27 is pretty obvious. It's going to be the number what?
3.
Thank you. Okay, and how about what kind of, is it enough to just leave a d right there? Like d to the third? That won't work because d times d times d is d cubed, not d to the sixth. So what power do we need on the d in order to end up with d to the sixth?
30.
Okay, now remember this, guys. A power to a power, you multiply. 3 times 3 would be 9, not 6. So what power do we need on the 6? That's right, Jack, 2. Right, so let's put a 2 right there. So we have identified by us setting this up, and that's why I wrote it up here on, or I printed it on the notes. You need to be able to set up, if it's a sum of two cubes, set up parenthesis cubed, or if it's a difference of two cubes, set up parenthesis cubed and parenthesis cubed, because that's the only way to identify what your A value is and what your B value is. That's the only way to identify the values that you're actually going to be plugging into your formula, which is going to ultimately be a binomial times a trinomial, okay? So this is the sum of two cubes, all right? I don't know, should we write the sum of two cubes formula or should we just go with it? We have a binomial times a trinomial. Let me zoom out a bit to make that trinomial bigger. What is that first binomial going to be if I apply the sum of two cubes formula? What is the first binomial going to be in our factored form?
2c plus 3d squared.
Excellent. You're going to take the same exact thing here, but without the cubes. So it's going to be 2c plus 3d squared. So let me do that. 2c plus 3d squared. And we know it is a plus because it was a plus here. And again, you just rewrite this, but without the cubes, and that's your first binomial. Now for the trinomial, this is where it gets a little more interesting. I am going to have to use parentheses here. I know that this is an a squared, and then if the binomial had a plus here, the ab here is going to be a minus. So I'm going to put a minus ab, and then plus b squared, okay? So our a value is clearly the 2c. Our a value is the 2c. And the b value is 3d squared, 3d squared, 3d squared. So as you can see right here, it's very important that we use parentheses on our trinomial. Because if you didn't use parentheses, you would, like back when I was in high school, I made the mistake of not using parentheses, and I would have 2c squared, and that's wrong. It's not 2c squared. What does this actually become? What does it actually become instead of 2c squared? What is 2c times 2c? 4c to the second. That's right, 4c to the second. All right, now the middle term, the minus, 2 times 3 is 6. C times d squared, just put in alphabetical order, C d squared. And last but not least, plus what? Come on, people. Wakey, wakey. What's 3d squared to the second power? Okay, I'm just going to say it. 9d to the fourth, right? 9d to the fourth. So we don't forget about the binomial that's out here in front, 2c plus 3d squared. Ladies and gentlemen, we have factored that above sum of two cubes binomial using the sum of two cubes formula. If you were to distribute 2c times 4c squared, 2c times negative 6cd squared, 2c times 9d to the fourth, 3d squared times 4c squared, 3d squared times negative cd squared, and 3d squared times 9d to the fourth, and then combine like terms, everything would eliminate except for the 8c cubed and the 27d to the sixth, believe it or not. Anywho, we will be able to use these skills to solve these equations. So a lot of us won't identify 216 as a perfect cube term, but it is. If you check it with the calculator, 6 times 6 is 36, 36 times 6 is 216. So we really do have a sum of two cubes formula going on right here. So let's first identify what cubed plus what cubed. That way we know what to plug in for A and for B. So we have an x for the A value and a 6 for the B value. So now we should be able to set up binomial times a trinomial, right? Because that's what it's going to equal. And the binomial is simply x plus 6. Now the trinomial, this is where I'm saying if you have a simple x and a simple 6 as your A and your B, okay, you technically don't need the parentheses, right? The first term will be a squared, which in this case will be x squared. And then if you did have a plus right here, the AB term will be a minus. So I'm going to put a minus AB, which is really A times B, which is really x times 6, which is really 6x. And then plus B squared, plus B squared, which is 36. So ladies and gentlemen, I have factored the original x to the third plus 216, and I factored it. Now I have a binomial times a quadratic trinomial. A linear binomial times a quadratic trinomial. Now keep in mind that this is an equation that's set equal to 0. So it's still set equal to 0, which means now I could either try to continue factoring by thinking what times what is 36, that if I combine together is negative 6. Like 6 times 6 doesn't work, 9 times 4 doesn't work. As a matter of fact, it's not factorable. Okay, so let's first do what we know. We know we're going to split it and solve. If you have something times something equals 0, you're going to take that first something and set it equal to 0. X plus 6, that's going to be set equal to 0. Then you have this quadratic trinomial equation set equal to 0. So this one's pretty easy. Subtract 6, x equals negative 6. That is an answer. Now the other one is a quadratic equation that's not factorable. So we don't just give up when we can't factor it to split it and solve. What do? We use the quadratic formula. That's right, the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And when we use this quadratic formula, we use parentheses when we plug in our b, our a's and c's. B squared minus 4 times a times c, all divided by 2 times a. So let's identify our a value is 1, our b value is negative 6, and our c value is 36. So we have a negative 6 here, an a value of 1 right there, and a negative 6 over here, the a value of 1 right there, and the c value of 36 over there. I know what you're thinking, dang, this is fun. Can't believe I'm getting all this entertainment for free. Yup. Anyway, the minus 6, that'll become plus 6. Let's start working on the discriminant that vocab word from semester 1, the value inside the square root. We have a negative 6 squared. That becomes 36. We have 4 times 1 times 36. That's going to be a negative, what is 4 times 36? Hey Siri, what is 4 times 36?
4 times 36 is 144.
144. All right, so that's inside the discriminant. Hey Siri, what is 36 take away 144? That is negative 108 according to Siri. So we have 6 plus or minus the square root of negative 108 as your discriminant, all divided by 2. So because we have a square root that's negative, we will end up with imaginary answers, but we need to find those imaginary answers. So what we have here is 108. We need to break down 108. So what I'm doing over here is I'm actually simplifying the square root of 108. I already know that the negative is going to be an I, but the square root of 108 becomes 9 times 12. 9, square root of 9 is 3. Square root of 12 breaks down 4 times 3. Square root of 4 is 2. So we have 3 times 2 times square root of 3, which means 6 square root of 3 is what we have. So I am going to replace the square root of 108. First of all, I'm going to put the I on the outside. So I have 6 plus or minus. We have an I on the outside. And then we also have times 6 square root of 3. Times 6 square root of 3, all divided by 2. So I'm actually going to multiply I times 6 and write it as 6I. So I have 6 plus or minus 6I square root of 3, all divided by 2. Now, we do see that we have 6, 6, and 2. Both of these are divisible by 2, so you might as well divide everything by 2. 6 divided by 2, 6 divided by 2, and 2 divided by 2. You'll have a 3, and no denominator of 2. So your final answer will be 3 plus or minus 3I square root of 3. So on this problem, on this ridiculously long problem, we applied a lot of knowledge, right? We learned the sum of two cubes formula. We applied it. We used the zero product property to split them, and we got one answer. And this one became a quadratic that we solved using the quadratic formula. We do have 3 total answers for this third degree equation. 1 is real, and 2 of them are imaginary. So I already know that the end behavior is going to be in quadrant 3 and quadrant 1. And I know that this squiggly line only touches the x-axis at one location, crosses through the x-axis at one location. That location is negative 6. Ladies and gentlemen, we are out of time. I hope this kind of made sense, and I recommend watching those videos, and please attempt to do your homework tonight, and we'll answer questions tomorrow, okay? I'm sorry for the long lesson. I'll see you tomorrow.